Okay, so in this video we will talk about solving a summation in which we have summation index squared times some parameter time to the power of that summation index, and that r is actually the absolute value is less than 1, and then I goes from 1 to infinity. Now in an earlier video we saw that we have, if the summation index is there without the square, and this guy is equal to 1 over 1 minus r squared. Now what we do is we differentiate both sides with respect to r. So differentiate with respect to r. So on the left hand side we can see that we have I times I minus 1 times r to the I minus 2, and on the right hand side we will get 2 over 1 minus r cubed, and then limits of I will be from 2 to infinity. Now the limits of I will be from 2 to infinity because if we put I is equal to 1 in this term, I minus 1, then it will make the whole term equal to 0. So we can just say that our term starts from 2 to infinity. Okay, now let's only consider the left hand side of this expression, and then we see that the left hand side is equal to, I'll just write it again here. So I is equal to 2 to infinity. Now this guy is equal to I is equal to 2 to infinity I squared or I minus 2 minus I is equal to 2 to infinity I or I minus 2. Okay, now remember that in the start we saw that we want to find the summation whose index starts from 1, but these summation here, their index starts from 2. So now first of all what I want to do is I want to write a general summation. If we have j is equal to 2 to infinity some function of j, and I want to evaluate from j is equal to 1, so what I will do, I will just subtract f of 1 here. So then this is a whole summation in which the function is evaluated from j is equal to 1 to infinity, and if I take away the value of function at j equal to 1, then I will have the whole summation in which the summation index starts from 2. Okay, so using this concept and writing these two summations so that the index start from 1, we will get I is equal to 1 to infinity I squared or I minus 2 minus, so if I put I is equal to 1 in this whole thing, what will I get? R to the power of minus 1, which is 1 over R. Then I have the second summation in which I have I is equal to 1 to infinity I R I minus 1, and then again if I put I minus 2, sorry about that, if I again put R is equal to I is equal to 1 here, I will get 1 over R here. So now you can see that this 1 over R and this 1 over R will cancel out, and we are left with I is equal to 1 to infinity I squared or I minus 2 minus I is equal to 1 to infinity I times R I minus 2. Okay, now a similar summation to this guy we already know the answer for. So what I will do is I will write this guy as 1 over R I is equal to 1 to infinity I r I minus 1. So now this is the summation which was our starting point here. So we already know the answer for this one. So the second summation will be 1 over r times 1 over 1 minus r squared. Now the first summation, this guy, again we want r I minus 1. So what we'll do is we'll just say 1 over r I is equal to 1 to infinity I squared r I minus 1. So then we have 1 over r. I just repeat it here. So this guy is equal to our initial right hand side, which was cube. Okay, so now it's a matter of just algebra now. So we will take this term on this side. So we have 1 over r I is equal to 1 to infinity r squared I squared or I minus 1 is equal to 1 over r times 1 over 1 minus r squared plus 2 over 1 minus r cube. So I can bring this r on that side. So I will get I is equal to 1 to infinity I squared r I minus 1 is equal to 1 over 1 minus r squared plus 2r over 1 minus r cubed. So which is equal to, now it's simple algebra will tell us that we have 1 minus r plus 2r. So which is equal to 1 plus r over 1 minus r cube. So in summary, we have I squared or I minus 1. This is equal to 1 plus r over 1 minus r cubed. Now this summation is very common when you want to find the moments of a discrete random variable, which we will talk about in some later video. Thank you for watching. Hope you liked the video.